So for our next example, we're going to find a Maclaurin polynomial to estimate cosine of x. And the way we're going to do that is well, first we're going to run through and get P0, P2, P4, but then we're going to use P6 to estimate cosine of 0.1. And the reason we're going to use a Maclaurin polynomial for this instance is because we want to center at 0. And the reason we're choosing 0 is because, first of all, cosine and sine of 0 are known quantities. And also the value that we're interested in, cosine of 0.1, should be, because cosine is continuous, very, very close to cosine of 0.1. So let's go ahead and get started. We know that we are going to have to find all the way up to the sixth derivative for cosine x. So let's do that first. So we need to have the 0th derivative, which is just the function itself. We need to have the first derivative, the second derivative, all the way up to the sixth derivative. And so these are actually quite easily computed because the derivative of cosine is cyclical. So starting with cosine of x, we move to negative sine of x, then to negative cosine of x, positive sine of x, back to cosine of x, and through again. And because it's a Maclaurin series, we know we're going to center at 0. So now that we have the derivatives, we need to evaluate them for x equals 0. So cosine of 0 being 1. All of the sine functions at 0, we already know that these are 0, so we can go ahead and handle those. And then we're just going to kind of flip-flop between negative 1 and 1. So negative cosine of 0 is negative 1, cosine of 0 is positive 1, etc. So now that we have all of our derivatives evaluated, we can go ahead and compute our nth degree polynomials for the Maclaurin approximation. So for P naught, that one's just f of 0, which is 1. For P2, we need f of 0 plus f prime of 0 times x to the first power, plus the second derivative evaluated at 0 over 2 factorial times x squared. And for this one, because all of the odd derivatives are going to be 0, we're just going to have 1 and then the second derivative. So that's minus x squared over 2, pardon me. So minus 1/2 x squared. For P4, we'll just write out the first 5 terms. And for us, that is going to be, so again, the odd derivatives are 0, so we get 1 minus 1/2 x squared. And then the fourth derivative is positive, so 1 over 4 factorial x to the fourth. And then for P6, it's the same thing, so let's just kind of copy these first 5 terms because we know we're going to need them here. And then we'll add on the next 2. So it's going to be plus the 5th derivative at 0 over 5 factorial, which we know will be 0. And then the 6th derivative evaluated at 0 over 6 factorial x to the 6th. And so this one's going to be the same as above, so 1 minus 1/2 x squared plus 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th. And so now that we have our 6th degree Maclaurin approximation for cosine of x, we can use this to get an approximation for cosine of 0.1. So this is P6, therefore just plugging in 0.1, enter that into your calculator and you're going to get 0.995004. And that actually, the first 6 digits here of this approximation are identical to cosine of 0.1. So just looking at that. Make sure your calculator is in radians before you push that through, and you would get the same answer if you truncated it at the sixth place. So the next example is a little bit of a trick question. We want to approximate the value of the natural log of 1.1. But it's also telling us to use a Maclaurin polynomial. So we know that we have to center it at 0. But look at our value, 1.1. That lets us know that we should let f of x be equal to the natural log of x plus 1. So this way, if we center this function at 0, we're going to be very, very close to 1.1 because we'll be at ln of 1. So if we're going to use, so we're using a 4th degree polynomial, so we need P4. So we need the first 4 derivatives. So we have our 0th derivative, our first derivative, second, third, and fourth. So let's compute those. So this is just the original function here at the 0th derivative. And then we'll get negative 1 over x plus 1 to positive 1, there we go. And then negative 1 over x plus 1 squared. Then 2 over x plus 1 cubed, and negative 6 over x plus 1 to the 4th. So now that we have our derivatives, we can go ahead and evaluate at x equals 0, because again, Maclaurin polynomials are always centered at x equals 0. So this is going to be the natural log of 1, which is 0. This is 1 over 0 plus 1. Negative 1 over 0 plus 1 squared. 2 over 0 plus 1 cubed. And negative 6 over 0 plus 1 to the 4th power. So we have all of our values we need in order to put the 4th degree Maclaurin polynomial together. So for P4, we have f of 0 plus f prime of 0 times x plus the second derivative at 0 over 2 factorial times x squared plus the third degree at 0, 3 factorial by x cubed, and then the last term will be the 4th derivative evaluated at 0 over 4 factorial times x to the 4th. So we can use the values we found above to write out an explicit form. So this is going to be, so f of 0 is 0, f prime was 1, so I just get x. Then the second derivative was negative 1, so I get negative 1 over 2 factorial times x squared. And then the third derivative was 2, so I get plus 2 over 3 factorial times x cubed. And then we move to negative 6 over 4 factorial times x to the fourth. And we can go ahead and simplify a bit further. So x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the fourth. So this allows us to approximate the natural log of 1.1 by just plugging in 0.1 into our polynomial. Because remember that f of x is the natural log of x plus 1. So plugging in 0.1 will bring us to an approximation for the natural log of 1.1. And so if we do this, what we'll end up with is 0.095308.3. And if you compare that to the natural log of 1.1, you would see here that we get 0.09531018. So it's a very good approximation.